We've used audio oscillators in earlier projects like Ear Splitter, Project 5, and Electronic Safe Cracking, Project 12. Capacitors play an important part in oscillator operation, as in this project. After you finish the wiring connections, connect the earphone to terminals 1 and 2 on the front panel of your kit. Press down on the key. You'll hear a sound through the earphone. Now release the key. What do you hear? You'll still hear the sound even though the key is not being pressed, but as you continue to listen, you'll notice that the frequency of the tone becomes lower. After a few more seconds, the tone will stop. Can you guess why this happens? Ah, come on! By now you ought to know the answer. The 100 microfarad capacitor is charged when the key is pressed. When the key is released, the capacitor discharges and releases enough electricity to keep the oscillator going for a few seconds until it is discharged. It's really simple, isn't it? There's another function capacitors have is oscillators that we haven't mentioned. But try this. Substitute a 10 microfarad capacitor for the 100 microfarad and change the 0.05 microfarad capacitor to 0.1 microfarad. What happens to the sound of the oscillator and how long it operates after the key is released? Try other values in place of the 0.05 microfarad capacitor. What happens to the sound? What does this tell you about how capacitors affect oscillator operation? Be sure to keep notes of your results. They'll be handy later when you want oscillator circuits to do certain things.
Now we're going to take the 10 microfarad capacitor, the 100 microfarad capacitor, and replace it with a 10 microfarad capacitor. It's a lot quicker with the 10 microfarad. Now let's take the 0.05 microfarad capacitor and replace it with the 0.1 microfarad. Notice that it made the actual oscillator frequency itself lower.
This has been a Cassette Master production.